Hi, today I'll be talking about friction. First of all, what is friction? Friction is the force that resists relative motion between two bodies in contact. There are many different types of friction, such as dry friction, and fluid friction. Dry friction is the friction between two solid objects, and it can be subdivided into static and kinetic. Fluid friction is the friction between a solid object as it moves through a liquid or a gas medium. And an example of this could be the drag force that an airplane encounters, or the water friction on the swimmer. In this video, we will be focusing on the static and the kinetic. Static friction. Static friction is the friction between two objects that are stationary relative to each other. In other words, they are not moving. And the equation for static friction can be expressed as force of static equals the coefficient of static friction, or mu static, times the normal force of the object. When an object is on the ground, how much force is required to move the object depends on this equation. Kinetic friction. Kinetic friction is a friction that occurs when two objects move relatively each other. And of course, the two objects must be in contact. The equation of kinetic friction can be expressed as force of kinetic equals to coefficient, or mu k, times the normal force of the object. How much force is required to keep an object moving depends on this equation. Usually, the coefficient of static is greater than the coefficient of kinetic. This tells us that the force required to move an object that is initially at rest is usually greater than the force required to keep an object moving. Now, let's take a look at some problems that is related to static and kinetic energy. Static and kinetic friction. Two sleds are tied together with a rope. The coefficient of the static friction between each sled and the snow is 0.22. The total mass of the first sled is 27 kg, and the total mass of the second sled is 38. An adult is pulling on the sleds. Question is, what is the greatest horizontal force that the adult can exert on sled 1 without moving both sleds, or either sleds? If the two sleds do not move when the adult pulls on the first sled, it means that the net force acting on the sleds is 0, and therefore the applied force is cancelled out by the force of the static friction acting on the two sleds. So by calculating the static friction of the sleds, we can find out the maximum amount of force that can be exerted without moving the sleds. So for this question, we can combine the two masses. 38 plus 27 gives us 65 kg. Since the equation for static friction is Fs equals mu s times the normal force of the object, we can substitute the numbers in. Fs equals to 0.22 times the normal force, which equals to mg, based on the Newton's third law, which states that if object A exerts a force on object B will exert an equal and opposite force back to object A. So the normal force equals to mg in this case, which is 65 times 9.8, which equals 0.22 times 65 times 9.8. This gives us 140 newtons. Therefore, the greatest horizontal force that the adult can exert is 140 newtons. Question B. Calculate the magnitude of the tension in the rope between sleds 1 and 2 when the adult exerts this force. So, let me just clear this. For this problem, we can draw a free body diagram for the second sled, with this force being the gravitational force, this the equal and opposite reaction force, this is the tension force, and static friction. Since the second sled does not move, the static friction must be equal and opposite to the tension force, so that both forces cancel out. Therefore, by calculating the static friction, it will tell us the tension force between the two sleds. And if we plug in the numbers in the formula, we'll get 82 newtons. It is 38 in this case because we're only calculating the static friction for the second sled. So the magnitude of the tension in the rope is 82 newtons. It is important to keep in mind that the normal force does not always equals mg. On a flat surface, yes, Fn equals mg because the force acting down will equals the normal force acting up. However, when the object is on an inclined plane, the gravitational force is not the same as the normal force. In this case, you would have to resolve this gravitational force into this component and this component. Then the magnitude of this component will give you the normal force. Well, that's it for my video. Thank you for watching it.